All right, here are your solutions. Here's question number 6 from 2019. Again, it's best if you do it first, right? And then press play and see where you're stuck. So if I read it, we have 3 functions, f, g, and h. And g at 2 and h at 2, they both equal 4. There's a line, and it is tangent to both g at x equals 2 and h at x equals 2. So we'll think of that in a moment. So it says, what's the derivative at 2? So tangent means derivative. And at h equals 2, this line is tangent. So therefore, the slope of this line is the derivative. So the answer to the derivative is 2/3. Let me try one more time. So tangent means derivative. And at 2, this is the tangent line. And the slope of the tangent line means derivative. So what's the derivative to? The slope of the tangent line. And the slope here is 2/3. If you want, you could write 2/3. You could have +4 at the end to know your x and y coordinate. But 2/3 is the slope. That's your answer. Part B. Now they have another function, a. So we have a at x equals 3x cubed and then h at x. I'm going to take the derivative and then plug in 2. So the derivative here is going to be the product rule. So that's the first times the derivative of the second plus the second times the derivative of the first. So that's 3 times 3, which is 9, and then subtract 1 to the exponent. Perfect. Now, after you take the derivative, I want you to plug in 2. And then part of this we don't need to simplify. So the first part I don't need to simplify, but I do need to know the derivative at 2, and we did that already. That answer is 2/3. What's h at 2 equal? So h at 2 is equal to 4. And again, I don't need to simplify this at all. Done. So you found the derivative and you plugged in 2 and you simplified only the parts that need to be. When it's just numerical at the end, you can let it go. Where are we at? Part C. So we have a function here, h. It is known that the limit as it's approaching 2 can be evaluated using L'Hopital's rule. So that means as it's approaching 2, I would get 0 over 0. So use that limit as it's approaching 2 to find f at 2 and find the derivative of f at 2 and show the work that leads to your answer. So we know, if I look at this, that then x squared subtract 4, that when you plug in 2, it gives you 0. We know that. The bottom. So when I plug in 2, it gives you the answer 0. So the only answer I would have for f at 2 then would be is equal to 1, because 1 take away 1 is 0. And then the second part is, what's the derivative that you would find? So next we'd have to take the derivative of both and evaluate it at 2. So the derivative on top, so we're going to do the limit as x approaches 2. The derivative on top is 2x. The derivative on the bottom, we're going to multiply with the exponent. And then I'm going to subtract 1 to the exponent. And then there's a hook. So this is the chain rule. And then I'm going to plug in 2. So we got 2 times 2. This is what I'm looking for. No, I'm looking for the derivative. We know what f at 2 now equals. And we're looking for this. All right, I'm going to simplify this. 2 times 2 is 4. we have negative 3 times 1, because we know f at 2 is equal to 1. And then we still have this derivative here is what I'm looking for, the derivative at 2. So I have 4 over negative 3. Oh, it's squared, right? That doesn't matter. It's still going to be give me 4 over negative 3 plus f prime at 2. What am I going to do next? F prime at 2, what would it give me? So we're using the L'Hopital's rule. We're plugging in. All right, so what do I have so far? I have, this is what I have so far. 4 over negative 3 and the derivative of f at 2. Oh, we know that when we plug in 2, so h at x equals this. We know that when we plug in h at 2, the answer is 4. Oh, there we go. I needed something. So there's the something I needed. So we're going to make it equal to 4. Notice both have a 4 in the numerator, so I can just take the denominator and then solve it. So add 3 to the other side, and I get the derivative at 2 is equal to 4. All right, last one. That was a tricky one. Is this one going to be a tricky one? Part D. It is known that g is smaller than h from 1 to 3. Let k be a function satisfying this. This is going to be called the sandwich theorem from 1 to 3, and is k continuous at x equals 2, and then justify your answer. So g at 2 is equal to 4. H at 2 is equal to 4. And the question is it continuous? So here at the beginning it says these things are twice differentiable. That means it's continuous. So if it's always in between here, that if g at x is continuous and h at x is continuous, then k at x must be continuous using that sandwich theorem. So this must be between 4 and 4. So is k continuous at 2? And the answer is yes. So because they are both continuous there and have an answer of 4, then this function's also, and this is called the sandwich theorem, that once in a blue moon shows up. But anyways, we're done. Mr. G Math over and out. Great job doing your work. Part C and D were a little bit whatever, but A and B, you totally got this. And we're not trying to be perfect. We're trying to pass this thing, and you can. All right? I'm proud of you. Mr. G Math over and out.